Question 15. The diagram shows the positions of these turbines A, B and C. A, B and C. A is 6 kilometres due north of B and C is 4.5 kilometres due west of turbine B. So our first task is to calculate the distance AC. So you should realise you've got a right angled triangle, you've got the two small sides, so Pythagoras rule will give you the third side. So we'll call them the side we want to find x. The rule then is that x squared will equal 6 squared plus 4.5 squared. And so we have to solve that equation. So we can simply do that by taking the square root of 6 squared plus 4.5 squared. Now that can be done on a calculator easily in one step. So I'll show you how that can be done now. So the answer is 7.5. So on to part B. Calculate the bearing of C from A. So we're going from A to C. So we've got to come round here, which is 180. So the first part is 180. And then the angle inside the triangle is the additional part to give us the bearing of C from A. So I'll call that angle Y for the moment, and I'll use trigonometry to find it. So the angle Y is 4.5 is opposite and 6 is adjacent. So if we use the tan formula, because tan gives us compares the opposite with the adjacent, then tan of our missing angle will equal the opposite 4.5 divided by the adjacent 6. I'll just make that clear here. That's the opposite, that's the adjacent, and just remind you that tan of any angle is the opposite divided by the adjacent. So we use inverse tan then to find our missing angle. So tan minus 1, 4.5 divided by 6 will give us the angle we need, and then we must remember to add that on 80. And you'll find that comes to 36.9 to one decimal place. We've been asked to give it to the nearest degree, so I'll correct further when I add it on. So I've got 36.9, which in fact I can change to 37 as we want it to the nearest degree. So 180 plus 37 is 217, and that's the correct answer to the nearest degree, 217 degrees.